Hey folks, welcome to another episode on our marathon episodes on matrices and determinants, the crash course. In this episode, we'll be talking about transpose of a matrix. The meaning is still hidden. The word trans and pose. We'll talk about that. In simple definition, if you just want to know in just one simple plain English and line, transpose of a matrix means you take a matrix and interchange the rows and columns. Just whatever is a rows will become columns and whatever is columns will become rows. And why do you do that? If you're interested to know more about that, what is the intuition and what does it get, I have put a separate intuition video on transpose of a matrix. You can check that and just appreciate the concept. If not, you can just follow along and stick to this particular byte episode and you should be just doing fine for the examinations. So transpose of a matrix is nothing but interchange of rows and columns, and it's denoted in varieties of ways, but this is one of the common denotation where you write, it's not to the power, but you write the matrix name in capital, whatever A, B, but A is normally used. And although you're putting a T, which means transpose in the power position, it's not a power, it's just a way of writing the notation. Just think about that. In some cases, some books also follow this. They put A and in the power position, not again the power, they just put a single quote like this, which means the same, transpose of a matrix, okay? And what it essentially does is, if you're going to have a matrix, if this matrix is given to you, say input matrix A, and if you're going to take the transpose, which is AT, and we're going to switch the rows and the columns, the order is going to be reversed. So if this matrix has 2 rows and 3 columns, and when you switch the columns and rows here, this matrix is going to have 3 rows and 2 columns. That's what it primarily is on this one. Another way to look at that, if you're interested, is you can think about this as a reflection on the backslash diagonal. If you take this diagonal here, so there's a reflection here. The diagonal itself does not change, this backslash diagonal, but the elements cross over. That's another way of looking at that whenever you want to, and that's what is exactly used also as one of the applications in graphics, where if you want to find a mirror image of a particular thing across certain X or Y axis or certain dimensions, you apply the respective transpose. That's one of the easy applications on that one. And like I said, I put a separate video. So if you see a lot of examples I put here, if you see this transpose, there's a 3 rows and 4 columns, and the rows and columns are reversed. Whatever is the first row will become the first column here, if you see that, and so on and so forth. So the order of this will be reversed. This will become a 4x3, where it has got 4 rows and 3 columns. Similarly, over here, if you see a 2x2 square matrix, the same stuff. It's easy to understand what it means. Over here, the first row is 1 and 2. This is row 1. This becomes column 1 over here, 1, 2. And this is row 2. And that becomes column 2. So the columns and rows are interchanged. And a lot of images I've put just for explaining it in different ways. If you see, it's a given matrix, and if you want to take a higher order, 3x3, right? This is 3x3 and this is 3x3. And if this is A, and this is the A transpose, or A T transpose, what does it mean? You just take this one row or one column at a time and switch whatever rows are there, it becomes columns, and vice versa, whatever columns are there, it becomes row on any matrix. That's a quick thing on understanding what's the concept of transpose of a matrix, interchanging rows and columns. That's it, and denoted by A, and there is not the power, but in the power position there is a capital T, or you can also get A and then just a single comma or single opening quotes kind of a thing. So that's a quick wrap up on this, and I'll see you in the next episode where we talk about other advanced concepts. Thank you guys.